We then enter El Nino. We officially entered El Nino in April of 2015. That is when the big Kelvin wave that had been stirring in the depths of the western Pacific Ocean right here finally made its ascent from the bottom of the ocean, and it's just a massive heat wave, and it made surface right here. Around April 9th was when the article came out in the Arctic News blog spot. They had been anticipating this El Nino for a long, long time, but finally in April it came to a head, and you can see right here in this temperature anomaly map, the El Nino is starting to form right along the equator, and you can see hot water starting to pile up here against South America near Peru as well. Interestingly enough, we've been talking about the Gulf Stream all this time. Take a look at the Gulf Stream. This is a temperature anomaly map. Isn't that interesting? You can see it right there. So this is actually a fascinating animation. This is an animation of the monster Kelvin wave that basically started the El Nino, and it came from the depths. So in the beginning of this animation, this Kelvin wave is at about 200 meters deep, and you can see it's absolutely huge. Look at the latitude markings on the bottom, and you can see it rose as its own distinct entity, kind of, from 200 meters deep up to the surface over a 2-month period of time, and finally surfacing there in April of 2015, kicking off the El Nino officially. So this is from February 2nd to April 3rd, 2015. And as I mentioned, this Kelvin wave is not unlike a lava lamp, and you can kind of see it has the same sort of motion if you remember those old-fashioned lava lamps that we used to have. Now this is kind of interesting. This is a comparison between two El Ninos. We had an El Nino that was super, super strong in 1997, and you can see that depicted here on the left-hand side. And also in July of 2015, this is how the El Nino looked. Now you can see that the El Nino in 1997 was indeed very, very strong, as the one in 2015 is starting to be, although it has not yet reached peak. It will probably reach peak November or December, and it will look a little bit different. But what I would like to call your attention to, in addition to the stripe of red, are in the July 2015 picture, you will see two blobs that are under Alaska and off the coast of California. These are anomalously warm regions of water that have been lodged and stuck there for about 3 years. This corresponds directly to the time period of the California drought. Let's take a look at the El Nino. We can see here that there are anomalies going over 2 degrees centigrade, and it will come to its peak in late 2015. So as a consequence of all this hot water that's going across the equator, that's an awful lot of energy, and consequently cyclones can form. And indeed, cyclones have been forming and kind of lining up like bowling balls. I mean, it's just been one cyclone after another in the Pacific. Of course, the Atlantic has had very little. But look at all these cyclones that formed within just 3 days in early July, July 3rd, 2015. We had 6 tropical cyclones form in just 3 days, all simultaneously, by the way. So take a look at this. Some of them are just low pressure systems, some of them are full-on cyclones, but they actually more or less mimic that red blistering line of the El Nino. And here's how the Pacific Ocean looked. So we have basically gotten ourselves a monster El Nino. This is how it looks in terms of temperature anomalies on July 12th, 2015. It is giving us back a lot of heat. All this heat that is coming to the surface and blossoming over by South America, this is heat that's going directly into the atmosphere, and this will cause additional heating in the atmosphere as well. Now, when water gets hot, it also gets bigger. It just does. So there's a big blister of heat directly on the equator going on right now because of the El Nino, and this caused a sea surface height anomaly that was actually seen by this satellite depiction July 21st, 2015. And you can see here in the white area, this sea actually got bigger because it got hotter. And in fact, some of the sea level that we've been seeing is due to warming seas and not melted ice. So sea level rise is affected by both warming of current ocean and by additional water being added by melting ice. Now, this picture is a lot more interesting than you would initially think. This picture is from August 16th, 2015, and I'd like to point out, remember that pool of warm water we saw off the coast of California and Alaska and all that? Well, it creates a high pressure zone, and it actually warms the atmosphere above it, and you can see the familiar counterclockwise motion as it's going there. So there's a counterclockwise motion going, and these are the storms from El Nino coming across, and you would normally expect these storms to go across and hit California with life-giving moisture. But in fact, that's not what happened. And what we have in effect is a situation where we have a pinball flipper sitting here off the coast of California under Alaska, pushing all these storms up to the Arctic rather than allowing them to go across to California and nourish California with life-giving water. So this is Pinball Wizard, and we have a pinball flipper that's basically taking these two storms here, which were down here, and these two storms did not go to California. These two storms went right up here to the Arctic, where they are not needed, going between the Bering Strait, between Siberia and Alaska. What we see now is that ocean heat is at a record high. The sea surface temperature anomalies are off the hook. Here's a picture from August 16th, 2015, and we can see sea surface temperatures and sea surface temperature anomalies, which the anomalies are more interesting to look at. This is the straight temperature. These are the temperature anomalies, and you can see clearly blistered right across here. Here's the El Nino, and here is the pinball flipper, and these storms get cycled right up to the Arctic. All of this is affecting our climate, and that leads us to the topic of abrupt climate change. So we're going to give a talk about abrupt climate change and see how the Arctic and how the general system is affecting us and leading us to a state of abrupt climate change, which we currently find ourselves in today. We are seeing extreme amounts of rainfall falling in short amounts of time, very short amounts of time, and very extreme amounts of rainfall at places all over the world. This is a phenomenon that I have called deluges. So deluges are striking all over the world. What is happening? Why are we experiencing so many of these severe weather flooding events that are supposed to occur only every 1,000 years or so? Will they keep occurring? Yes. What city will be hit next? I mean, who knows? It just happens all the time. I'm sure somebody can answer that, but certainly not me. Here's an interesting question. Can the Alberta tar sands be hit by such a deluge event? And if they were hit by a deluge, what would be the implication? Well, I think we can all say safely that if the Alberta tar sands were hit by a deluge event, all of that poisonous material that they've been unearthing would be directly put into our water system, and who knows where it would go. It would be horrible. So hope that doesn't happen. So we are seeing deluges happen worldwide. Deluge is a word that has now found its way into our vocabulary, brought to us by abrupt climate change. So what we see is that atmospheric water vapor in the world is increasing a lot. In fact, for every degree that the atmospheric temperature raises, we see 7% more moisture in the atmosphere. So we are currently tracking to between 4 degrees centigrade and 6 degrees centigrade as far as our temperature that we're going to be raising. And just imagine what that will do to the moisture saturation levels in the atmosphere. And just especially considering that water itself is a contributor to global warming. Did you know that water vapor is actually a global warming gas as well? It is. It's a huge effect. So we're seeing scenes like this. This is becoming pretty typical. We are now facing an angry climate. So says Paul Beckwith, this picture taken up in Canada around the Calgary floods that happened last year. Now, when the temperature keeps going up and the humidity keeps going up and the water vapor keeps going up, we can get into a situation where we have something called wet bulb temperatures. And these pose a great threat to us here, life on Earth, in this time of abrupt climate change. What is a wet bulb temperature? Well, at 100% humidity, a temperature of 35 degrees centigrade or 95 degrees Fahrenheit proves fatal within days or hours to people in good health. James Hansen has said, even a person lying quietly naked in a hurricane-force wind would be unable to survive such temperature. And that is because if we can't shed our waste heat, our organs fail and death results. And if we have 100% humidity, we can't evaporate and we can't get cool. So we're seeing higher temperatures in the southern United States, and some of them are getting very dangerous, and these are getting dangerously close to wet bulb temperatures. So take a look all down through the south of Texas and Houston and New Orleans and Baton Rouge and all those places. They are all getting very hot and very humid, and this is going to be a very difficult situation for people.